Okay. All right, so now we're going to go over some troubleshooting and maintenance of this system. So first of all, I'm going to go over all the parts because the system is very modular. The way the system was originally built is that all of these parts were built into this little cube. And as pieces broken, we kind of took equivalent parts and kind of set them all up. So I'm just going to go down the list and show you what each one of these parts does. Right here, this is our exhaust valve controller. As I briefly mentioned before, this valve back here controls whether the vacuum line is open to the chamber or not. Um, Depending on the vacuum set point, it will open or close that valve by degrees to basically in a feedback loop get to the set point pressure. So when this is on the external, it will just continuously hold that valve open. On the internal, it activates the feedback system to keep it at that set point that you've set. The rest of this is just set up so that it properly reads the actuator on the motor. So it should be kept at 1 volt for the input, and then all this phase and gain stuff, shouldn't really worry about it too much. What you could change about it is how quickly the feedback occurs. But in general, you don't really need to worry about this too much. Down here, we have a pressure relay. This pressure relay connects to the pressure gauge in here. That is a capacitive membrane pressure gauge. You can see it's this kind of black cylinder back here. So that gauge connects to the internal readout. This internal readout connects to this relay. And as you can see, there's a slight discrepancy between the two. That's something to keep in mind when you're setting your set points and starting your plasma. Next up, we have our mass flow controllers. This controls how much of the gas flows through. First of all, for it to work properly, these ratio switches should both be off. Second of all, if you're getting no reading on here, it's possible that the connections to the actual mass flow controllers behind the system, the contacts might have come loose. So very simply, if you get that issue, you can unplug this connection here at the top of the mass flow controllers. If you unplug it, plug it back in, it may solve an issue where you're getting zero reading on your mass flow controller. So it's kind of simple as that. Make sure all your contacts are properly connected. Nextly, I already talked about the active tuning that might have to be done when you're striking a plasma. So while your power is on, you may have to actively tune using this switch here. Finally, it's very important to know exactly what this system can handle, and it's very important to match your load to your RF power. So if you're not familiar with the proper working pressure of the system, or of the process gas that you're using, and you're not familiar with the proper flow rates, basically if you don't know the recipe and you're just kind of trying things, you have a high probability of damaging the RF line. Reason being is because the way the RF line is connected, you can kind of see it right here on the very inside. This line is one of the connections to the RF power. See right in there. It's hard to see, but on the back water line, you can see that there's a RF line connected there. That was done when the RF power source was disconnected from the internal one. Basically, what this effectively does is it has the bottom plate, or has the metal water cooling lines kind of act as the effective cathode of the RIE, rather than the actual bottom plate, which it would be fed to. So you have the top plate acting as your anode, the bottom plate acting as the cooling lines acting as your cathode. And if you improperly match the RF power to the pressure in here and the gas in here, there is a small seal that seals the water lines. So instead of delivering your RF power to the gas, and if it's way unmatched, you'll be delivering the RF power to a rubber seal, which will burn out and cause the vacuum in this chamber to completely go off, and essentially you'll have to take this whole thing apart and put a new seal in there. So again, if that happens, if you essentially break if you mismatch the load to the RF source enough, you'll break that seal, and you won't be able to get any sort of RF power or any sort of plasma. So again, you just have to take apart that water line, replace that seal, put it back together. You'll know it's not working because whenever you try and strike a plasma, the reverse power will be at max, which is 36 watts. If you see that it's going to 36 watts, that means it's completely reflected. Other than that, as far as troubleshooting, it's kind of like any other vacuum system. So if you're having leaks, it's important to check every joint of your vacuum system that you can. Check for any damaged seals. Other than that, it's also important to keep the vacuum pump in good condition. So that means regular oil changes, regular maintenance in general. Other than that, that's mostly what we've experienced troubleshooting this system. The good thing about it is it's all very modular, so you can tell exactly which part of the system is not working at any one time. Kind of makes it easy to determine what's going on. And then from there, it's kind of just taking things apart and making sure it works.